Okay, so continuing with pHs, pH of a strong acid. Let's have a look at a few calculations. Okay, carrying on from last time. Just so you can see how I'm using a calculator. Let's say we have a 0.05 molar, which I'm usually using. This is also moles per dm cubed. Okay. Now, if I've got a solution this strength, 0.05 of HCl, as in the original, the first video we got through, the hydrogen ion plus chlorine, what happens is all this 0.05 moles of HCl will dissociate into H plus and Cl minus, and so we have got 0.05 moles in 1 litre, 0.05 moles of protons. Looking at the equation, if that's what you like, pH is equal to the minus log the base 10. You don't write that, you won't find that in the calculator for your hydrogen ions. What I do, rather than write out an equation, sort of a formula, I go, and this is the scientific calculator on Google, press log 0.05, that's our concentration, press equals, and we've got minus 1.3, and we'll leave it minus 1.3. So minus 1.3, so you can see exactly what I put in. Different calculators do different things. So we've got minus 1.3. However, we just pressed log. Let's just change colour. We pressed the log button. We had nothing to do with this sign here. So all I do is I just get rid of the minus sign, 1.3. For those mathematicians, I multiply this by minus 1. Yeah, just to make it slightly clearer. So the pH of a 0.05 molar solution of hydrochloric acid is 1.3. Okie dokie. So let's have a look at the other way. So if someone turns around to me and says, Mr. Iqbal, and they tend to say that, we have got a solution with a pH of, let's say 2.5. What is its concentration? So I'm trying to find out, the question is, what's the concentration of hydrogen ions in moles per litre? Well, the first thing I do is I multiply it, I do the opposite. I get rid of the sign, it's a positive, I reverse it to a minus 2.5. So what I want to do, and I haven't seen before, I'm really poor with this new fancy technology, I clear this, and I want the opposite of log. I think it's inverse. I press inverse log, that should work, and it will, 10 to the power of x, so inverse log, and what do I have? Minus 2.5. Aha! And there we go, 0.0031. Let's call it 0.0032. 0.00, how many zeros? 2 zeros, 0.0032 moles per dm cubed. Moles per dm cubed. So what I'm going to do is double check that, because I haven't used a calculator before. So if I was going to find out the pH of a solution of this strength, I would take my 0.0032, let's clear it, I'm going to log 0.0032, get the answer, and I got minus 2.49, 2.5 because I rounded it up. So yeah, it works brilliantly. And there you go, we've gone from concentration of hydrogen ions in this session through to pH, and then taken the pH and gone back through to concentration of hydrogen ions. Okay, as per usual, any questions or any additional information you want, leave a comment.